So I want the fuel efficiency of the worst 20% of cars. And again, that's the lower numbers, okay? So there's a key in our calculator, and it's called inverse norm. It is in the same menu, second distribution, and it's number 3. Same menu as normal CDF. It does the inverse of normal CDF. And you get a screen that asks for area. You're going to leave mu and sigma as 1. And then some of us have a calculator that asks tail, left, center, right. Okay. So here is the command. Again, that's second distribution, and then down to number 3, inverse norm. I just reinserted it. My area that I'm interested in is 20%. It has to go in as a decimal, 0.2. Okay? I'm going to leave these the same, and my picture showed the lower boundary, right? The left side of the normal model. And so I'm going to select left. And then I'm going to hit paste. And then I'm going to hit enter. So I had 0.2. I chose left. And then it's negative 0.842. Now, with inverse norm, I usually use about 4 decimal places. So we may do that. Your calculator, how many of you did not have the left, center, right option? A couple of you. Okay. So when you don't have the left, center, right option, you're always going to put in the left percentage. That's what it does. It'll calculate from 0 to the number you gave it. So that means if you wanted the upper 20% and your calculator doesn't do left, center, right, then you have to actually ask it for the lower 80%. Okay, so if your calculator doesn't do the right, if I wanted the upper 20%, I would choose right if I have that option instead, or I would put in 0.8 because the area to the left is what the calculator is going to only calculate if you don't have that option. Okay, so 0.2 if you have the right option. 0.8 if you have no LCR option. Okay. Yes?
Will those weird Greek symbols ever change?
No. What are those weird Greek symbols?
Sigma.
Mu. What does that represent? Mean. And sigma is standard deviation. This is, yes, it's mu and sigma. Mu and sigma will never change. You are always going to leave them at 0 and 1. Okay. So now I have a z-score. I have a z-score and I have a mean and a standard deviation. Can I find the actual fuel efficiency, the x? Remember our equation, x minus mu over sigma. So my z-score is 0.8416. The more decimal places we use, the more accurate our answer is. I always like 4 decimal places when I'm talking about the z-score and I'm working backwards. So that is equal to x minus the mean of 24 divided by the standard deviation of 6. That's some pretty basic algebra. Hopefully we can solve this. Multiply both sides by 6. And since you have it in the calculator, I just hit times 6. I don't round when I am doing the calculations in my calculator. I don't round in my calculator. You should not either. So instead of retyping, instead of retyping 0.8416 and rounding it, I just hit times 6 because that's going to keep the unrounded answer in my calculator, and my final answer will be most accurate. And then negative 5.049 is what I'm going to write down equals x minus 24. And then I'm going to add 24. So I get x equals 18.950. Hold on. Move that out of the way. So the worst 20% of cars get less than 18.95 miles per gallon. So next is what gas mileage represents the third quartile. So the question is, what percent of data is below the third quartile? Caleb?
For the last problem, we had 20%, and we used that as 0.2. So does that mean for this problem, we'll use 0.75?
Yes, 75% of the data is below quartile 3, right? And if we haven't kind of talked about this, I apologize, I thought I did, that in a box plot, between the minimum and Q1 is 25% of the data. Between the Q1 and the median is also 25% of the data. Between the median and Q3 is 25%. That's why they're called quartiles, a quarter of the data. And then the last is also 25%. So your Q3 has 75% below it, and your Q1 is 25% below it. Okay? Which also means 25% of the data is above the third quartile. Okay, so I need to do inverse norm. And I'm going to write it down like this. This is how we write our command, 0.75. I will always do inverse norm with only the left button. For those that do not have the left, center, right. So I will always do only left. Okay, because some calculators don't have it. And that is 0.6745. Let's see if my brain's working still. 647. Yep, nope, I was right. 0.6745. After decades of teaching this, I have certain z-scores memorized. And you will too after we get towards the second part of this class. All right, so that gives me my z-score. So remember that inverse norm gives me a z-score. Normal CDF gives me the percent given a z-score. Does that make sense? Normal CDF needs the z-score to give you a percent, and inverse norm, you tell it what percent you want, and it tells you what z-score represents that. So then, same calculation. 0.6745 equals x minus 24 over 6. So we'll times by 6 and add 24. And we get x equals 28.047. That's still an ugly 8. So the third quartile of gas mileage is 28.05 miles per gallon. In your sentence, it's okay to like round a little bit more, but your final answer needs to have those 3 numbers behind the decimal. Questions so far? And the last question was what? Ooh. What gas mileage, or describe the gas mileage of the most efficient 5%. And understand that all of my data is old. Our book is all, at this point, our textbook is 11 years old. So 11 years ago, we didn't have the Teslas. We didn't have the Prius. We didn't have our hybrids that got better gas mileage. So the data we're looking at is based on old stuff, okay? And when we get into like the next chapter, you'll have to bear with me as some of your problems might ask you to predict what might happen in 2020. Nobody would have predicted what happened in 2020. I guarantee you that. But we might be making predictions about the past because our book is so old. And I was going to try to get a new book, but we were all virtual and, you know, they weren't going to be nice to me like that. So the best 5% of fuel efficiency. So what does the best 5% of fuel efficiency look like? If we look at a normal model, the best is going to be up here, right?
So 0.95?
Right. So the upper 5% is the best, but if I'm using the left key, I'm looking at what is that z-score? Okay, this z-score for the lower 95%. The value is going to be the same because it's this z-score that represents where 95% is below it and 5% is above it. So we're going to do inverse norm, 0.95. Now, if you have left, center, right, you can do 0.05 right. But number one mistake is forgetting that I have a 0 in front of that 5. 5% is 0.05, not 0.5. 0.5 is going to give you the mean, right? Halfway. So make sure you convert your percentages correctly. Move that decimal place twice. Inverse norm 0.95 should be 1.645. Let's pull it up and make sure. Yeah, 1.645. So this is my z-score. So I plug it in. And we'll times by 6 and add 24. $33.869 miles per gallon. So the best the most efficient 5% of cars get more than 33.87 miles per gallon. Last example, what if it asks for the IQR of fuel efficiency? This is in your homework tonight, so pay attention. And as soon as I finish this example, I'm going to let you start your homework. Yes, Caleb.
Once you just find 0.75 and then subtract that from 0.25.
Right, the values, the x values for that. Correct. So I need to find my inverse norm, 0.75, that's Q3, which is 0.6745. And Q1 is inverse norm, 0.25, which happens to be negative 0.6745. Why? Because my normal model is symmetrical, so if I'm 25% above the mean and 25% below the mean, the only difference in my z-scores is one's negative and one's positive. Okay? So I have to find the two x values. Didn't we already find this? Yeah, Q3 is, I'm going to actually put Q3 here so we know. We found Q3 up here was 28.047. So Q1 multiply by 6 and add 24, and I get Q1 equals 19.953. So my IQR is 28.047 minus 19.953. So the IQR of fuel efficiency is 8.094. That's the middle 50%, is that spread out. And it's still miles per gallon.